Good evening to everyone. So my name is Lim Liang Hui, and we are from Linjie 40303 Electric Magnetic Field and Wave from session 4 and 5. So we are from Good Ed, and our group member have Nawaz, Amin, Hanuddin, Najrak, and me. So our assignment title is electrostatic touchscreen. So we can see nowadays everyone are using a touchscreen devices. For example, we have the iPhone, iPad, and our phone. Also nowadays our laptop also can touchscreen. We have the 2-in-1 laptop, something like that. And also I think smart TV also can touchscreen. So for the introduction, the electric charge. Electric charge is a fundamental properties where same charge will repel, while the opposite charge will attach to each other. So it will forming a basic of the electrostatic phenomena. As you can see at the figure, the positive charge and the negative charge will attach to each other. So it will attach it. And also when we have a same charge, it will repel this also. For the objective, in this assignment, we need to demonstrate the concept of the electrostatic touchscreen. We need to know that how we finger when we touch a monitor, the devices will know where are we touch it and it can censor it, the place, the position of the touch. So secondly, we need to ensuring the components installed and functioning properly. We need to make a product and install it and also function it properly. Lastly, we need to assemble and produce a functional sample prototype. So for the problem statement, the problem of electrostatic discharge. So the as we call is ESD will make a problem when we touch it. So it may influence the inductions of capacitor touch display. So the ESP will make our touchscreen devices known as to sensor. The sensor will not too specific at that position. So we need to solve these problems. So next one, we need to start our product. So for the prototype analysis, when the main components which has the ribbon of the sensor that allow the capacitor touch that register will operational. The prototype will work. The primary monitor screen will display the coordinate when press a rectangular point. So when we is a place, the monitor screen will display it. So for the block diagram and flowchart, of course we need to start first, and then we need to use our finger to touch the screen. The screen will detect it, and then the IC will calculate touch position. In this experiment, we use the MPR 121 capacitive touch sensor to calculate the touch position. So next one is interpret touch cluster And also last one is as skills action. So the monitor will display where we touch it and the end. So for the discussion, it carry out the product to discover how the constructor Cooper will react with a touch of our finger to disrupt the uniformity of the field at that specific location. So now I want to show something about our product. As you can see it here, we are connect a Cooper wire, a Cooper coil with a wire. So this we have the 6 short Cooper and connect cross with 4 long Cooper like this and connect with a wire. And this experiment reveals MBR121 IC. So this IC, we need to connect it this 12 with the wire. After then we can see it. These are the final product of our did it. We firstly with a Cooper and then connect with to a IC. After then we go through with a display and the monitor will display it. It will calculate it where we touch it and then will display it here. So I want to play the video right now. As you can see, where we touch it and the monitor will display it. Okay. Even though we are very fast and also move like this, the monitor also will detect it. Okay. As you can see here. So this is function very well. So for our conclusions, the NPR121 capacitive touchscreen experiment, touch sensor experiment in touchscreen devices demonstrate the remarkable capability of calculating the task coordinate due to the successful integration of electrostatic. So I think that's all from our presentation for the topic electrostatic touchscreen. And I want to mention again, we are from Good Egg. So that's all for me. Thank you. So as you can see in our experiment, we can note that when we touch it, wherever we touch, the monitor also will display at where. Even though we just shrug it like this, the display, the IC also will sensor it and it will calculate it to make the position that we touch it will also can know it and monitor also can display the position. So for the conclusion that I said just now, the MBR121 capacitor touchscreen, I think is a stronger IC that can be used in any type of devices because it can detect wherever we touch it. But the size of this touch sensor will a little bit bigger. So when we make it a small touch IC, it can be placed at any type of devices, such as our phone. So we need to have a small sensor, then we can use this. So I think that I need to add something about for the ESP. When we have done it and the experiment, we need to know that how to solve this problem. And in this experiment, we just add on a plastic cover to decrease the electrostatic discharge. So it will make the monitor can display the position more specific, can display more detail of where we touch it. So I think that's all from our good. Thank you so much. And I need to mention again, we are from Good and our title is electrostatic task quick. So thank you so much.